The electric field in an electromagnetic wave is given by this equation. Using it, you need to find the direction of propagation of the wave, the amplitude of the magnetic field, and you need to write the vectorial equation for the magnetic field. Let's start by comparing the equation given for the electric field to the general equation for the electric field that is part of an electromagnetic wave. That equation will be written as the electric field vector as a function of position and time equals the amplitude of the electric field, or the maximum value of the electric field, multiplied by sine of k is the wave number, y is position, minus omega angular frequency multiplied by time t, multiplied by a unit vector that shows in which direction the electric field is actually oscillating. I have written this equation to match the equation given by the problem. So from this equation you can see that the electric field oscillates along the z-axis because the electric field is written as a function of the unit vector k, which is oriented along the z-axis. Also, by looking at the position that shows up in the parentheses, you see that the position is along the y-axis, which means that the electric field propagates along the y-axis. If the electric field is propagating along the y-axis, then the magnetic field is also propagating along the y-axis, and the electromagnetic wave is traveling then in the plus y direction. Why plus? Because the sign in the parentheses here is negative. If this sign were to be positive, then the electromagnetic wave would have been traveling in the negative y-axis. Now for the second part of the problem, we need to find the amplitude of the magnetic field. There is a relationship between the maximum value of the magnetic field and maximum value of the electric field. The maximum value for the magnetic field equals maximum value for the electric field divided by the speed of light. Replacing with numbers, we have 3 times 10 to the 5th is the maximum value of the electric field given by the problem. And the speed of light is 3 times 10 to the 8. That gives us a value of 10 to minus 3 Tesla for the amplitude of the magnetic field. Now, in the last part of the problem, we need to write the vectorial equation for the magnetic field. That equation is very similar to the equation for the electric field. The magnetic field will propagate along the same direction as the electric field, will be equal to the amplitude of the magnetic field, or maximum value of the magnetic field, multiplied by sine of ky minus omega t. And now the only thing we need to figure out is what unit vector to use for the magnetic field. Remember, magnetic field propagates in the same direction as the electric field, but it oscillates perpendicular to the electric field. So let's consider an xyz coordinate system. We know from the problem that the electric field oscillates along the z-axis. The z-axis is coming out of the page. We also know that the electromagnetic wave travels in the positive y direction, so the velocity is in the positive y direction. And we also know that the direction of the electromagnetic wave is given by a vector that has the same orientation as the cross product between the electric and magnetic field. If we consider that the magnetic field oscillates along the plus x-axis, because the magnetic field has to oscillate in a plane perpendicular to the electric field, we can choose either plus or minus, and we take the cross product between the electric and magnetic field, the resultant will be oriented along the y-axis, which means that indeed the magnetic field oscillates along the x-axis. So the unit vector that I am choosing is unit vector I. All we have left is replace with numbers, and we have that the magnetic field as a function of position and time will be equal to the maximum value of the magnetic field is 10 to minus 3 Tesla multiplied by sine of, and as you can see from the given problem, we have the value of k, 10 to the 6 meters to minus 1. We have the value of omega, 2 times 12 radians per second, multiplied by the unit vector I.